In 2026, the most effective park ranger in the African savannah doesn't wear boots, doesn't carry a rifle, and, it doesn't even need to sleep.
Right, because it runs entirely on a neural networks.
Exactly. It's just lines of code. And today, we are looking at how the messy, deeply unpredictable reality of the wild is being protected by the cold, calculated logic of artificial intelligence.
It is a profound shift. I mean, we're
Yes.
taking the most advanced computational tools humanity has ever built.
So the ones usually stuck in those sterile, climate-controlled server rooms.
Yeah, exactly. And we're just throwing them headfirst into the mud and the rain and the canopy.
So welcome to today's deep dive. Our mission here is to explore how the future of wildlife conservation might actually be written in software.
Yeah, it's fascinating.
It really is. We are working from this excerpt from an AI News Digest. It's dated March 23, 2026, and it's basically breaking down a report from MIT Technology Review.
Right, the one focusing on the Bay Area.
Yeah, specifically how the animal welfare movement out there is actively recruiting AI. So, okay, let's unpack this. Because if you are listening to this right now and you're, I don't know, building machine learning models or engineering software or even just tracking the tech space,
This fundamentally changes how you view edge cases.
totally. You aren't just optimizing for like click-through rates anymore. The edge case here is quite literally the survival of an endangered species.
Precisely. And I think why you should care about this is that we're finally witnessing the technology break out of its standard corporate bubble.
Right. We always hear about AI optimizing supply chains or, generating synthetic media.
Yeah, making videos or writing emails. But applying that immense predictive power to tangible organic survival
Yeah.
in some of the most remote places on Earth.
Yeah.
That forces us to solve entirely new engineering and logistical problems.
And to understand how those problems are actually being solved, we have to look at where the specific convergence started.
The MOX meeting.
Yes. The MIT report highlights this gathering in early February. It was at a San Francisco co-working space called Mox, and the setting is incredibly specific. They had these colorful canopies overhead, Persian rugs all over the floor, and a strict no shoes allowed policy.
Which sounds very Silicon Valley, but
Right, it's not just quirky interior design, it's really about who was sitting on those rugs.
what's fascinating here is the deliberate disruption of standard operating procedures.
Yeah.
Think about how high-level tech architecture is usually designed.
Usually in boring boardrooms.
Exactly. Driven by rigid agendas, everyone wearing their professional armor. Mox intentionally stripped that away. By forcing everyone to take their shoes off and sit on the floor, the environment engineered a physical vulnerability.
I love that, a physical vulnerability.
Right. You had hardcore AI researchers, people whose entire worldview is built on deterministic code and super clean data sets, sitting barefoot across from field biologists.
People who spend their lives dealing with stochastic, unpredictable, messy ecology.
Exactly. Animal welfare advocates who are out there in the dirt.
It's almost like a cultural exchange program. Or actually, no, it sounds more like they were trying to merge two completely different operating systems.
That's a great way to put it.
Because you have the tech side speaking the language of compute latency, predictive modeling, algorithmic efficiency, and then the conservation side is speaking the language of migration patterns, poaching vectors, biological necessity.
They literally had to build a shared compiler just to communicate with each other.
Yeah. The conservationists possessed the chaotic ground truth, right? The desperate boots-on-the-ground problems.
And the engineers held these incredibly powerful hammers.
Yeah.
But they needed the biologists to show them where the nails actually were. Stripping away all that corporate friction allowed them to just ruthlessly interrogate each other's assumptions.
But, taking off your shoes in the San Francisco office doesn't actually stop a poacher in the Serengeti.
No, it definitely doesn't.
So how do we cross that massive gap? The groups at MOPS realized they couldn't just rely on standard cloud architecture. Transitioning from a theoretical brainstorm on a rug to a muddy jungle requires entirely different infrastructure.
Which brings us to the actual tech, the concept of the digital park ranger.
Yes. Let's get into the digital park ranger. The cornerstone of this system is the deployment of AI-powered drones. But we have to be super clear here. We are not talking about just strapping a GoPro to a standard commercial quadcopter.
No, definitely not.
No.
Because if you are monitoring a massive wildlife reserve hundreds of miles from the nearest city,
You don't have a 5G cell tower.
right, you can't just beam terabytes of 4K canopy footage back to an AWS server for processing.
So how does it work?
Well, the compute has to happen locally, on the device itself. This is where edge computing becomes absolutely critical.
Okay.
These drones are equipped with onboard neural networks that process the visual data in real time. They aren't streaming video to a server, they're streaming insights.
Wow, so the drone scans the landscape, the local model analyzes the frames, and if it sees nothing, it just dumps the data.
Exactly. It discards it to save power. It only sends an alert, which is just a few kilobytes of data, over a low-bandwidth satellite or radio link, when it actually spots an anomaly.
Here's where it gets really interesting. Because they aren't just using computer vision to spot, like, an animal silhouette, the MIT report details how these machine learning algorithms are getting incredibly granular.
Oh, the tiger stripes.
Yes. For instance, they use computer vision to map the unique stripe patterns of a tiger. They essentially treat those stripes like a human fingerprint.
That's incredible.
Right. So the drone can identify not just a tiger, but that specific tiger, tracking an individual's health and territory over months, and they never even have to tranquilize or tag it.
And we really have to look beyond just the visual data, too, because one of the most powerful tools discussed at MOX was actually acoustic monitoring.
Right, because a dense rainforest canopy totally blocks a camera's line of sight.
Exactly. But sound cuts through the canopy. So AI models are being trained on vast acoustic data sets to monitor the auditory health of an ecosystem.
Okay, wait, I have to ask, how does an AI actually listen? Because, I mean, my smart speaker gets confused if the TV is on in the background.
Right, yeah.
So how does a model deployed in the middle of the Amazon distinguish the sound of a poacher's chainsaw from, say, a sudden tropical downpour? Or just a really loud insect?
It's wild, but it actually does it by converting audio into visual data.
Wait, really?
Yeah. The AI doesn't listen the way you and I do. It generates a spectrogram.
A septiptogram.
Right. It's a visual representation of the spectrum of frequencies of a sound as it varies over time, and then it runs an image recognition algorithm on that spectrogram.
Oh, wow. So the visual signature of a revving chainsaw engine looks entirely different on a spectrogram than a falling tree.
Or a cicada, exactly. The model can isolate that specific visual shape of the sound, triangulate its location using multiple sensors, and instantly alert a ranger patrol.
It's basically acting like an ecological immune system.
That's a perfect analogy.
Because it isn't just flying around hoping to catch a poacher red-handed. It maps the baseline temperature, like the normal heartbeat of that specific forest.
And machine learning thrives on establishing that baseline.
Right. So when a herd of elephants suddenly shifts their migration route a day early, or the whole acoustic profile of the canopy goes silent, the system detects the fever before the threat is even visible.
Exactly. It's relentlessly scanning for deviations.
But wait, I have to push back here for a second.
Sure.
Because if you're working with ML, you know a model is only as good as its training data.
Very true.
If we train this ecological immune system purely on historical movement data,
Right.
won't it just fail spectacularly when faced with unprecedented climate events?
Oh, yeah.
Like, say there's a sudden flash flood or a completely unseasonal drought brought on by climate change. The animals will behave erratically just to survive. If the baseline is broken by an external climate anomaly, doesn't the AI just get overwhelmed? I mean, it would just start throwing endless false positives, effectively blinding the local human conservation expert, right?
That is the exact vulnerability that keeps the engineers at MOX up at night. You are entirely correct. If the model is rigid, a climate anomaly just breaks its predictive power. It will flag literally everything as an emergency.
That's what's the fix.
This is why the architecture relies on a continuous, human-in-the-loop feedback system.
Okay, so the human expert has to step in and retrain the model on the fly.
Effectively, yes. So the AI detects the anomaly like the chaotic movement of the herd. It alerts the human ranger. But then the ranger uses their deep organic intuition to look at the situation and say, oh, this isn't a poacher, this is just a reaction to the drought.
Ah, I see.
The ranger then labels that event in the system. So the model uses that local real-time human expertise to dynamically update its understanding of the baseline.
So the machine provides the scale, processing thousands of acres simultaneously, but the human provides the contextual wisdom.
Exactly.
It's essentially battlefield triage. The AI scales the vision, highlights the critical sectors, and the human applies the judgment.
But navigating that partnership, like moving from a theoretical collaboration to actually keeping a drone airborne in the Congo, introduces massive logistical friction.
Oh, I can only imagine. tremendous friction.
Yeah, and the report makes it very clear that the groups at Mox weren't just high-fiving over cool tech. They defined three distinct pillars of challenge that this integration must overcome to actually function out in the wild.
Right. And those systems must be accessible, ethical, and beneficial.
Let's dig into those pillars.
Yeah, let's start with the first one, accessible. This makes total sense to me because if this AI acoustic sensor array costs $500,000 and requires a team of MIT PhDs to calibrate it every single week,
It is completely useless.
right, useless to a local conservation team operating on a shoestring budget.
Exactly. Accessibility in this context means ruggedization and democratization. You are dealing with severe swap constraints, size, weight, and power.
Right, you can't put a massive, power-hungry GPU on a little solar-powered sensor tied to a tree.
Exactly. So the tech industry had to utilize something called tiny ML.
Basically shrinking the models down.
Yes, mathematical quantization.
Yeah.
Taking these massive neural networks and stripping them down so they can run efficiently on incredibly cheap, low-power microcontrollers.
And those can survive for months on just a tiny solar panel.
Right. And that drives the cost down from thousands of dollars to literally a few bucks per sensor, making it accessible to underfunded reserves.
Which leads directly into the second pillar.
Hmm.
It must be ethical. And we aren't talking about like abstract philosophical ethics here. We are talking about highly practical security and biological protocols.
Yeah, the stakes are very real.
Because if you successfully build a system that maps the real-time GPS coordinates of the last remaining rhinos in a reserve, you haven't just built a conservation tool.
No, you've accidentally built a precision targeting system for the exact poachers you're trying to stop.
It is the ultimate double-edged sword. If a bad actor intercepts that data stream, the conservationists have inadvertently done the poacher scouting for them.
Exactly.
So how do you solve that? Because the reserves need to share data to improve the AI models, but they absolutely cannot risk the actual location data leaking.
This is where they deploy federated learning.
Okay, break that down for us. What is federated learning?
So instead of sending the raw data, like the video feed or the exact GPS coordinates of the rhino, up to a central server to train the main AI model, the training happens locally, on the edge device itself.
Oh, I see.
The central server sends the baseline model down to the local sensor. The sensor learns from the rhino's movements, gets slightly smarter, and then only sends the learned weight updates, the mathematical improvements to the algorithm, back to the central server.
Wow. So it's essentially training the brain locally and only sharing the upgraded synapses, not the actual memories.
Precisely.
So a poacher intercepting the transmission only gets a string of complex weight updates, not a map to the rhino.
Right. The data privacy is mathematically baked into the architecture itself.
That's brilliant.
And, the ethical pillar also extends to the physical impact of the tech.
What do you mean?
Well, if you were flying drones over a herd to monitor them, but the acoustic signature of the drone's radars causes a spike in the animal's cortisol levels.
Oh, stressing them out.
Yeah, disrupting their feeding or mating. Then you are actively harming the ecosystem. So the engineers actually had to redesign flight paths and rotor acoustics specifically to minimize the biological stress footprint.
Which perfectly sets up the third pillar. It must be beneficial, like it has to actually serve the animals.
If we connect this to the bigger picture, it addresses the classic solutionism trap that plagues Silicon Valley.
Solutionism.
Yeah, it's when you develop a brilliant, shiny piece of technology and then wander around looking for a problem to force it onto.
Right, the old, I have this amazing hammer, let me go find something that looks vaguely like a nail. It's so easy to imagine a tech startup releasing slick PR footage saying, look at this incredible 3D mapping our drone did of a tiger reserve.
While the local biologist is standing there saying, that's great, but did it actually help us stop the tiger from being killed?
Right.
And the animal welfare advocates at Mox hammered this point home. The rainforest does not exist to be a sandbox for AI developers to stress test their algorithms. Every line of code, every hardware deployment must be ruthlessly evaluated on whether it delivers a measurable biological benefit to the ecosystem.
So what does this all mean? If you are listening to this and maybe you're analyzing your own tech stack or your project roadmaps, the lesson from this MIT report is that whenever we try to solve organic, messy, real-world problems with deterministic digital tools, we are stepping into what the source accurately calls an ongoing experiment.
Yeah, you cannot just push an update, hit deploy, and assume the jungle is going to adapt to your software.
Because the natural world doesn't issue bug reports via a ticketing system.
No, it doesn't. The feedback loop is biological survival. If the code fails, the consequence isn't a dropped packet. It is a lost species.
The feedback loop is biological survival.
Wow.
The stakes literally do not get any higher than that.
They really don't.
And it completely reframes how we think about the utility of artificial intelligence. It pulls it entirely out of the realm of just, making businesses run 5% faster or generating consumer entertainment.
When you place these advanced computational tools in the hands of passionate, multidisciplinary teams, teams willing to strip away their egos, take their shoes off, sit on a rug, and bridge the gap between engineering and ecology, AI transforms.
It really does.
It stops being a mere tool for commerce
Yeah.
and becomes an active, vigilant shield for the natural world.
It is an incredibly hopeful paradigm shift. And for you as a listener, regardless of what specialized field you work in, I think the ultimate takeaway here is to aggressively look for those unexpected intersections. The fusion of neural networks and canopy ecology is absolute proof that the most innovative, world-changing solutions almost always come from colliding wildly different disciplines together.
This raises an important question, though, something for you to mull over as you go back to your own work today.
What's that?
For generations, we have largely viewed technology as the wedge that separates human beings from the natural world. Technology built the concrete walls, the combustion engines, and the glowing screens that keep us indoors and isolated from the wild.
Right.
But if artificial intelligence allows us to finally perceive the hidden complex patterns of a living ecosystem, if it gives us the scalable tools to actively protect these habitats rather than just exploit them, could technology actually become the very mechanism that reconnects us to nature? Could our most advanced artificial creation be the key to preserving the untamed world?
What a profound thought to end on. From the sterile, blinking lights of a server room, directly to the breathing, muddy reality of the wild. We started today talking about how diametrically opposed those two environments seem, but maybe they're exactly what the other needs to survive. Thank you so much for joining us on this deep dive. Keep challenging your assumptions, stay curious about where your own expertise might unexpectedly intersect with a new world, and we will catch you next time.